Morning, Pottingers class. Today we were working on 1.3 multiplying numbers that end in 0 and
Exponents.
And we should be able to use exponents and numbers that end in 0 to do some multiplication, right? Yes. All right, so here we go. A factor. Factors are numbers that are in what kind of problem?
Multiplication problem.
Multiplication problems have at least how many factors?
2.
2. Can they have more than 2?
Yes.
For sure. A power is a number written with an...
Exponents.
And an exponent is that little tiny...
Number.
It's a little tiny number above the base, right?
Yes.
We'll look at those in a second. The base is not the little tiny number, but it is the...
Big.
It is the bigger number, right? So when you think of myself and my wife is the... The wife is the...
Exponent.
And the base would be me. Okay? Standard form, expanded form. Standard form is just kind of really, really condensed. But expanded form is really stretched out. True or false? True. Expanded form is really, really stretched out. Okay. Multiplying numbers end in 0. Let's do this quick. I have 9 times 10. Do you guys know how to do that really quick?
Yes.
James, you can sit down so people can see. Great. I just multiply my non-zero numbers first, right? So what's 9 times 1? 9. And then what do I do with this leftover 0? I add it on. 9 times 100. What's 9 times 1? How many zeros do I add to that?
2.
So I get 900?
Yes.
Okay, I'm going to go down here. What is 90 times 30? 27. 2,700, right? What I did is I multiplied the 9 by the 3. Guys, what's 9 times 3?
27.
So it's 27?
No. Yeah.
No. Listen to what I'm saying. What is 9 times 3?
27.
I need all eyes up here. Again, I have people not looking up here. We're supposed to be looking at the front of the room. I'm going to ask again. What is 9 times 3? 27. How many zeros do I have in my factors?
2.
So how many zeros do I add on to the end of 27?
2.
So my final answer for 90 times 30 is 2,700. Okay, here we go. This is a power, yes?
Yes.
Okay. The little tiny number is the,
Exponent.
and the big number is the base. So down here we have a pattern. We have a base, which is,
4.
and we have a base, which is,
4.
so the base is always going to be what? 4. Okay, our exponent, I'm going to start with this exponent right here. That exponent tells me how many times to multiply the base, right?
Yes.
So an exponent of 2 says we multiply the base.
2 times.
So do we just go 4 times 4 then?
Yes.
If you have an exponent of 4, how many times would I multiply the base?
4 times.
So 4 times 4 times 4? Times 4? Yes? So this piece of information right here, to calculate powers, you just multiply the base the number of times the exponent says, yes?
Yes.
If we have it really stretched out, we call that what form?
Exponent form.
But if the answer is just the answer, that is called,
Standard form.
I should be up here. And if we have just the problem written as a power, we also call that,
Standard form.
how many 2's do I have here?
7.
So we can say the base is 2 because it's 2 over and over and over again, right? And how many times is the 2 being multiplied?
7 times.
So it's 2 to the power of 7.
Yes.
Last thing we did here was a word problem, yes?
Yes.
Abby on her bike trip. In the word problem, we had 3 different parts that we needed to break down. Get your head off your desk. Get your head off your desk. Get your head off your desk. Thank you. We had 3 different parts we needed to break down. If you show your work and if you just write things down to solve a word problem, does that make the word problem a lot easier?
Yes.
So my advice is break word problems down into small, tiny little problems so that you can solve what's being asked of you. Yes?
Yes.
We good?